Okay, so we have been discussing how to put a system of equations, three variables, into triangular form. It's an equivalent system that's way easier to solve. And the way we do it is we first eliminate the x in all but the top equation, then we eliminate y in the last equation, and then if we have to, multiply by some sort of constant in order to make the leading coefficients equal to 1. So let's do one example together, one more of these, to write this in triangular form and then solve it. Okay. So the first thing I want to do, of course, is label my equations with an A, a B, and a C. And I want to eliminate the x in all but the top equation. So I can do a couple of things here. I could, if I wanted to, look at equation C down here. In equation C, x already has a leading coefficient of 1. So I could just exchange that with A and get it right up on top and start from there. Okay, but I don't have to. I can do a whole bunch of different things to start off with, and I might be led to a different but equivalent system at the end. But since these two things are exact opposites, and A and B, the x's are, let's just go ahead and add A and B to replace equation B. So that's what we're going to do. A plus B to replace equation B. So A doesn't change. It stays 2x minus 4y plus 2z is equal to 16. Okay? And then if I add A and B together, the x's are gone. I will have 1y. I would have 4z's plus 4z is equal to a negative 34 plus 16 is a negative 18. Okay, and then equation C stays the same. So x minus 2y plus 2z is equal to 4. Okay, so the next step that I'm going to do is I have to get rid of this x right there. So to get rid of that x, what I'm going to notice is that the top equation, look at the top equation. The top equation has nothing but, well, it's all even numbers, so I could take half of that if I wanted to. So why don't we take half of that, and so that the leading coefficient there is going to be 1. So I'm going to take 1/2 of A to replace equation A. So half of that is x minus 2y plus z equals, not 16 anymore, but 8. Okay, my next equation stays the same. Y plus 4z equals negative 18. And the bottom one is x minus 2y plus 2z is equal to 4. Okay, so again, what I need to get rid of is this x. So I can do that if I just do a negative a plus a c to replace equation C. So I'm going to do a negative a plus c to replace equation C. Now, just to help myself out a little bit, I'm going to go here with, say, red. I'm going to change all of these signs here. So it's going to be negative x plus 2y minus z equals a negative 8, just to make it easy to add those things up. Okay, but whenever I go to write down equation A, I'm going to keep the original one, which was x minus 2y plus z equals positive 8. Equation B stays exactly the same as well. Y plus 4z equals negative 18. And here's my new equation C. So negative x plus x gives me nothing. A positive 2 plus negative 2 gives me no y's. Hey, that's very convenient. And then finally, a negative z plus 2z gives me z. And that should be equal to negative 8 plus 4 is a negative 4. Did I do that right? Yep. Okay. So look, I've already put it in triangular form. I'm almost done in order to solve this. I already have my z coordinate. It is negative 4. In order to find my y coordinate, just plug that into the second equation. So I would have y plus 4 times negative 4 is negative 16 equals negative 18. So adding that thing over, y's got to be equal to a negative 2. Okay, and then finally, in order to find my x coordinate, We can stick it into any one of the original equations. So why don't I just stick it into C here? So x minus 2 times negative 2 is plus 4. And plus 2 times z, so that's a negative 8, should be equal to 4. Okay, solving this for x, that is x minus 4 is equal to 4, which means that x is equal to 8. So my final answer then is 8, negative 2, negative 4. So we just used maybe a half a sheet of paper in order to solve this by putting it in a triangular form using elementary row operations.